Hello, everybody, and welcome to another episode of the Let's Talk About Data show. So, we've got a really good show lined up for you today, and I've got two superb guests, great friends of mine and colleagues. So, we're going to be talking about how to accelerate your GenAI projects using knowledge bases on PostgreSQL. So, for those that don't know me, I'm Tony Mullen, a database specialist solutions architect, and I'm one of your regular show hosts for Let's Talk About Data. And I will let our guests introduce themselves. So, do you want to start, Domenico?
Yeah, sure. Thank you so much, Tony. I'm a database specialist solution architect too in AWS since 4 years and a half now. I'm based out of Italy, and I'm focused on relational database services, particularly with PostgreSQL based database services. So happy to meet you all.
Cheers, Domenico. And Steve, want to
Yeah,
go?
hi folks. So my name's Steve Wood. I've been with AWS about 3.5 years. I too am a database specialist solution architect, specializing in open source databases and Postgres. I'm very happy to be here today and looking forward to doing the demo.
Cheers, pal. And so, do let us know where you're tuning in from today. So I'm based in Manchester. Steve, where are you based? Let us know where you're based.
I am based, so we share the same office, don't
You're
we?
not far from me.
Yeah, I'm based over the Pennines in West Yorkshire, halfway between Huddersfield and Leeds. So that's me, a place called Gunsall.
Yeah, and Domenico's a little further afield. Where are you, Domenico?
Oh yeah, definitely. As I said, from Italy, I'm based out of Milan, but I live in Bergamo. That is, let's say, 50 kilometers on the east, far from Milan.
Near the
Yeah,
airport.
near the airport. Yeah, there is a couple of airports.
Where there
in
is the
Milan.
airport, yes,
Yeah,
yes,
everyone will know which airport.
Bergamo Airport.
Yeah.
BGY, yeah.
And do let us know, like I say, let us know where you tune in from. I'm just talking about how cold it is where everyone is as well. So, let us know if you're tuning in from somewhere nice and warm, because we're certainly feeling the cold at the moment. So anyway, let's get going on our topic, because we've got lots of things to talk about today. We've got some nice demos as well. So, and we don't have a lot of time. So let's get going. So I've got some questions here now. We'll start with some questions, and then we're gonna move along to a demo. So let's start with, what is the main challenge with current GenAI applications and chatbots, you would say, Domenico?
Oh yeah. I'm just wondering how many of you have used chatbots, such as those that they are available on the market today, and I guess probably all of us have used those chatbots, and I wonder how many of us have sized those tools provide made up, completely invented information, and I think this sounds familiar to you. And it's, I would say, a very common problem. And this is what we call the problem of hallucinations, right? And it's, sometimes the reason why a good part of GenAI projects um, um, fail, never landing to production. But the good news, and this is, what we are going to describe you today, there are many solutions, and one of the solution we are going to show you today is basically combining uh, powerful technologies such as the knowledge bases and Postgres, to overcome this problem of hallucinations. Definitely. Yeah.
Yeah, I mean, it's a good point. I think everybody's using some form of AI, isn't they, today? Chatbots for sure. People are familiar with them. So, but like you say, how does it actually work under the covers? So,
Yeah,
we'll take a little sneak behind those covers today and show you how it works a little bit and how you can accelerate your project. So, what is a knowledge base then in context of generative AI?
You wouldn't like to go, Steve, or I go?
Either or. Yeah. So basically, a knowledge base is a pool of your own data that you know to be correct. And so you are using it in something called a RAG use case, so retrieval augmented generation, whereby you use it to reduce your chances of hallucinations. So you're in a sense checking the information that your LLM is going to give you with factual documents that you know to be true. And so basically that can be used to help reduce the chance of having these hallucinations with your system.
Yeah, and I think I have a slide for this. Hope it is visible.
Yeah, let me get that up on the screen. Yeah.
Yeah, so basically, you can think of it as a personal library of the artificial intelligence, but not just as any library. It's rather like a highly organized and instantly searchable collection of information. And it consists of four key components. That is basically the document storage, and you can consider it as the AI's long-term memory. The vector embeddings, a numerical representation of data that preserves the semantic of the original object. And it also simplifies the calculations that you can do with it, right? And then the metadata, and well, think of it as the organizational system, like when, for example, you tag your photos, cities, and places on your mobile phone, for example. And last but not least, the indexes to support the fast searching within a collection of millions, if not billions, of embeddings stored within the database. Yeah.
Nice one. Let's say a quick hello to a few people in the chat. So we've got Jeff is our producer today. So as he said, put your questions in the chat. So here he edits. Hello, he's one of our regular viewers, and watch him from LA. Lucky person. And then we've got David here. So it's 16 degrees C. You're showing off. I wish I was there in ATX. I don't know where ATX is. Do you know where that is? And this is a great topic. Yep, I'd agree. It's a good topic. Cool. Let's get moving on then. So we've just been talking about knowledge bases. So how are they useful in context with GenAI, and how are they able to reduce hallucinations in your responses?
Yeah, I can take this. Basically, we can consider these two questions as the two faces of the same coin, likely. Basically, you can leverage your data to differentiate your GenAI applications, providing more context to the large language models, right? That is the main concept. And the LLM response quality is only as good as the context. And there's two main types of context, right? One is the situational context that basically provides the operational data to the model. And if, for example, this is part of an ongoing conversation, you can provide relevant conversation history and state, which is called, of course, the situational context, as I said, right? And also, if you have info about the user, let's say, why not to make your response more personal to them? And this data is usually retrieved from your data stores. Plus, there is the semantic context. That is, basically, it refers to the AI's understanding of the meaning, relationships, and the broader implications of words and concepts within a given text or conversation, and it is added to the prompt through the process of retrieval augmented generation. That is the RAG, the commonly known as RAG.
Yeah, nice one. So, and also, how are we helping with AWS then in this space? How are we helping customers?
Yeah, well, I can make multiple examples, but for the sake of the time, I will just provide one. AWS provides some very useful services in this area, right? Such as, for example, Amazon Bedrock. I'm mentioning Bedrock because it provides a choice of leading foundation models that are, quickly and easily accessible through single APIs. The benefit of this is that, you customer, you can experiment and choose the most suitable model for your knowledge bases. These foundation models are offered by leading companies such as Anthropic or Amazon itself, for example. Then you can customize these foundation models to adapt them to the specific needs of the knowledge bases that you are implementing. It provides native support for retrieval augmented generation, and that's the point of this conversation, because basically this knowledge allows you to enrich and refine the model's answers with information that is retrieved from your knowledge base, thus reducing the phenomenon of the hallucinations. It supports the agents when you need to execute multiple, let's say, autonomous multi-step tasks. And of course, last but not least, Amazon Bedrock provides built-in security, privacy, data governance. That is critical when working with knowledge bases, because they often can contain sensitive or proprietary. And
Yeah.
well, probably let's say last benefit, I think probably the most valuable benefit is that with the Amazon Bedrock you can consider it as sort of an orchestrator, because normally what you want to do, what you would like to do is I don't know if the screen is still visible.
Yeah,
Because
I can bring that up. Let's get that up now. Yeah.
yeah,
There we
well,
go.
let's say this is a typical RAG process that is composed of multiple steps, and basically, normally, what you will do is to build from scratch and orchestrate building your own process. All those components in your system to basically provide the final answer. Starting from the user query, ending up with the system response. But with Amazon Bedrock, all these steps are just performed for you and implemented for you. The integration between all the system components is provided by the service. Yeah.
Yeah, and we'll see this in action in the demo as well.
Yeah,
What we've got
exactly.
today. So we'll see this all flowing. Yeah, because it's kind of a bit like opening Pandora's box a little bit, and you can see what's going on, and that we'll see some of that today, which is great.
Yeah.
Cool. So, I mean, we've talked a little bit about vectors there. So, vector embeddings. So, why are they important, vector embeddings?
Yeah, well, as I already said, vector embeddings are a numerical representation of words, phrases, or entities in a multidimensional space. For a multidimensional space, I mean something like this. This is a very, let's say, simplified example with three dimensions, but it's just to give you an idea. So the main purpose of vector embeddings is basically, on one side, preserve the semantic meaning of the unstructured data. And for unstructured data, we can refer to documents, so text, videos, audios, in a format. But well, this process of embeddings will transform this unstructured data in something that is in a format that allows for efficient mathematical calculations and comparisons. So in a format where we can easily apply formulas on top of that data, right? And well, this will enable the GenAI application to understand similarities and relationships between words or entities, basically, right?
Yeah, computers work a little bit better with numbers, essentially, don't they?
Exactly.
They do
Exactly.
they do with the words. Yeah, and they are some big numbers as well when you look at you look at the vectors. So, so I mean, here's another one for you. Why choose Postgres? So, I mean, we're all pretty Postgres guys. So we're probably a bit
Yeah,
favored in
definitely.
that space. But why? Why would you choose Postgres?
Yeah, for us, it's an easy answer. We are specialized in Postgres, so why not use Postgres? I would say. But basically, it offers several advantages. Let's say, that uh, first of all, it's an open source project with almost now 40 years of active development, with a very active community, and supported by many organizations all over the world, not a single organization, right? And among them, I can mention, just the most contributors I would say Enterprise DB, EDB, AWS itself. We are one of the main contributors in the community, Microsoft, and many others, right? Then PostgreSQL offers ACID compliance, robust data type implementations, native partitioning capabilities, and in this context, the two most benefits, in my opinion, are extensive index support and extensibility through extensions. So basically, related to these two last benefits, Postgres, and when I say Postgres, I also consider and mean Amazon RDS for Postgres and Amazon Aurora Postgres compatible. Postgres supports a very important extension. It's called pgvector, right? This extension basically effectively transforms Postgres into a valid solution as a vector data store because it allows Postgres to efficiently store the embeddings, so the arrays, with specialized data types. And it adds searching capabilities for similarity searches with a bunch of comparison operators and specialized indexes, of course.
Yeah, and it's had a lot. PG Vector gets a lot of active contribution, doesn't it, as well?
Yeah.
And it being not part of the core part of Postgres means you are getting up to date versions of PG Vector. On a regular. You'd have to wait for a brand new version of Postgres for that.
Yeah, and
which is pretty cool.
Yeah, definitely. We have, inside AWS, we have people actively contributing to this project.
Yes. Yeah, we do. Cool. So I think let's go to demo time now. I'm
Cool.
really keen to see this in action. So shall I share your screen, Steve? Yeah.
Please. Yeah. Okay. Yeah. So what I'm going to show you first of all is I have set my Linux environment variables so that I can connect to Postgres Aurora cluster unchallenged, and the first thing I'm going to check is whether we've installed our vector extension. So and
it's probably worth mentioning for this then. So this demo you're going to be doing is using a Bedrock knowledge base, and you're using Postgres as your vector store in this scenario. So what you're doing here is just some of the prereqs for that.
Yes. But before even the prereqs, I'm just going to show you a very simple idea of what a vector is. So cool. just to aid your understanding of it. So what I'll do is I'll create a little test table called in my embeddings, and it's very simple. So I'm going to drop it because I already created it. A little test run, and so now we've got our table, and you can see what that looks like. So it's very simple. It has the vector type. So in configuring that extension gives you the vector data type. We can then install or insert, rather, I should say, some rows into this table, and you can see our vectors now. These only have three dimensions, and a typical vector that's used in a database might have 1,000. But just as a very simple use case, so we've got 4 rows defined here, and I can query the table normally, and I can see that it just contains a simple set of IDs to vectors. However, if I use a operator, a L2 operator that I'll show here, it will actually taking the first one, so our first embedding, which was a simple 1, 2, 3, and this is the operator that calculates Euclidean or L2 distance from the vector of 1, 2, 3. And so here we look at the results of that. So the distance of 1, 2, 3 from itself is obviously 0. And if we go to these, the furthest from 1, 2, 3 is the direct opposite of it, which is 3, 321 that gets the highest distance score there. So that's just a very simple representation of what vectors are when they're stored in the database. Obviously, the embeddings will be much, much bigger, but it just gives you a quick example of that.
There's a nice little example of that.
So what we'll do now is we'll create our table that we're going to use for our knowledge bases. So tables that are used by knowledge bases have to have a certain subset of columns, and they have to have an ID or a column that you're going to use as a primary key, and they have to have your vector field, obviously. In this case, note that rather than a vector of 3 attributes, now it's got 1,536, so that's far more typical. It's got chunks, which stores the chunks of data that you're actually going to that are representing the embeddings themselves. Then it has some metadata that Bedrock uses and needs to store in JSON format. So these fields here have to exist. So now I'm going to switch to Bedrock, and what I'm going to do is I'm going to go build and then knowledge bases, and I'm quite zoomed here in here, but we've got an option to create a knowledge base, which is what we're going to do now. And in our case, we're going to create a knowledge base with a vector store. There are other options here. You can use Kendra, which is like a fully managed database that you don't get to configure and you can't use for other purposes like you could with Postgres. So with Postgres, we can actually just add these columns to existing tables. We can just create it as a new table in our existing schema. So compared to Kendra, it gives us that far more flexibility, essentially. So that's what we're going with in this case. I'm just going to keep the defaults, just the default knowledge base name. I'm going to have it create an IAM role for us. So you can see we've got various sources or that we can have for our store. So we can use Salesforce, we can use SharePoint. In this particular case, I'm going to use a Amazon S3 bucket for that. And now I'm going to go next. Now I'm going to browse the bucket that I want to use, and I have a knowledge base bucket created earlier, so I'm going to select that. And now some various options, default chunking, which when a embedding model processes a document, then it does it in tokens, because it will actually help the embedding model process the data in smaller chunks. Rather than having a very large vector on the entire document, it will chunk that vector up or chunk the document up, and so it can process it easily and it manages memory better. And so that's why you define the chunking strategy, but I'm just going with a default one here that uses 300 tokens. And so I'm going to continue. So select model. For here, I'm going to use Amazon and Titan embeddings G1. So these are our text embeddings models. So this isn't the same thing as an LLM. So a LLM might give you that chat interface to your data, whereas a text embedding model takes your data, takes your statements, takes your documents, whatever it may be, and then converts them into text embeddings. And when they're converted into text embeddings, then all this contextual information about that particular object has been produced into embeddings by this Titan embeddings model. So not to be confused with the LLM in this case.
Yeah.
Now here we get to choose what we want to have as our vector store. So I'm going to use an existing vector store, and I'm going to select Postgres, so Aurora Postgres serverless. And here I have to fill in details. So this is the cluster resource name, I will give it my database name. So you would probably pick a different database name. I'm just going with the default here. That was the name of the table that's been created. Have I created it? Yes, I did. So just need to check that always. The secret ARN, because Bedrock still needs to be able to access and gain and authenticate against your cluster. And the vector field was embedding, if you remember here. Yeah, so that's the column that contains vector embedding. Chunks was where we're storing the text representation of our data. Metadata is the column. We're not going to provide any custom metadata. ID, if we refer back, was our primary key column. And so we're going to go next. And so it gives you a summary page here. And so we can scroll down, and when happy, we can go create knowledge base.
So pretty simple and easy to set up.
Very simple,
when you
I
get
think.
going with it.
Yeah. And then that goes on and does its stuff. It creates the role. And depending on whether we've got time, I'm going to give you a quick example of this, and maybe we can get, so this knowledge base by chance. Okay. So what have I not done here? So in order to work correctly, this needs indexes on this table, because it's not going to let you create a system that performs horribly. And so on our vector store column, we do need a index on here. So it's a HNSW index. So hierarchical navigable small world, if I can put my teeth in to say that. We also need one on the chunks or the text column as well. And so that is what this error was about. It may
should let you do it. Yeah, I think
it may let me do it, or I may have to restart the process. Let's have a look. Let's see what it does. Okay, I'll just try it one more time, but it probably wants me to go through the process again.
Try doing previous, see if it'll work. See if you go back one.
No, okay, I'll just whiz through this very quickly.
Oh, you've got to love the joys of a live demo. We like it. Yes.
No, I feel I've self-sabotaged.
Let's put the pressure on now, Steve. Come on, you can do it.
So we'll very
it's good though to show that. I think it's a good point though to show that
it is. I mean, it's not going to let it's not going to let you create a system that performs horribly. It just won't let you do it. So that's
and later on, maybe likely discussing the best practices to accelerate the usage of the knowledge bases. We will see how those two different types of indexes can help with the hybrid search.
Yes. Okay, so we're just going through the same thing, picking the table name, secret ARN.
Yeah.
Field name.
And it's worth mentioning as well, you can call those field names anything you like as well, can't you? These just happen to be I think the documentation, these are kind of defaults, aren't they?
Yes.
I think that's looking better now. Yeah.
Yeah.
There we go. Great. Yay.
Okay, so at this point, I will explain the details about the PDF that I've loaded into that S3 bucket. So I had already loaded a PDF document into that S3 bucket. And it was this. So a little bit random, but I think random things were better here. So this is a historical document written in 1930 about the history of the village where I live, going back centuries and centuries, right back into the Middle Ages. And I was used a test case of one particular bit of this document where it talks about a weaver called Eve, who was confined to Bradford prison for non-payment of debts. So poor old Eve had been thrown into jail because she owed someone money. So random, I know, but it works best with random things that aren't commonly available in Google, or
because
or that
it's like your data, isn't it?
likely
You know,
to
stuff
trawl.
what's not there.
Yeah, exactly. So here's our knowledge base. So I'm going to, the first thing I need to do is I need to sync, because it currently doesn't know about the document that I've put in to our S3 bucket. So it's going to sync and check that it's got that. Now it has done, we can test it.
So when you're syncing, just to make it clear to everyone, when you're clicking sync, can you explain what is happening with that document? Because it leads back to a bit like what the diagram Domenico was showing earlier.
Yeah, okay. So this is where your document is being processed and it's being passed to the Titan text embedding model, and it goes through a process of tokenization. So this is breaking the text into individual
I'll quickly
words.
just show Domenico's screen as well. Let's just put that back up again.
Yeah. Okay. So it goes through a process called tokenization, where it's breaking the whole body of text into words or subwords, and then it inputs them into your embeddings model. And and the whole document is chunked, and this allows better memory management to stop a single vector requiring enormous amounts of contiguous memory, because that wouldn't work. And so what you get from this is a series of these things that look a lot like arrays, but what they actually contain is a whole load of contextual information about your document. And it doesn't have to be a document, it could even be a video, it could be an image, it could be anything, providing your embeddings model supports it. And so that's the power of it. So rather than you adding 1,001 attributes or flags describing a particular object, that's what your embedding model is doing. It's doing that all for you.
Yeah, and I guess knowledge bases as well are building that whole process as well. That workflow, you'd have to build that yourself without a knowledge base, which will take some significant effort to do that. And then the second piece of the puzzle is what we'll see now, which is the test piece you're doing. So let's get that up. Let's just share that, bring that back to the stage. Here we go.
Okay. Right. So what we've got here is we're going to pick ourselves a model. So this is a large language model. We'll pick Haiku in this case, Claude 3.5. And so this will give us our chat interface to this. So it's not going to, and immediately after this, what I'm going to do is I'm going to switch to the default LLM that you can test within Bedrock, and we will compare the answers. But the question is, what was Eve of Gummersall confined in Bradford prison for, and when? And so let's see what the knowledge base answer to this is.
And basically here, coming back to the diagram I was showing before, it's the step 4 and 5, where the user question is embedded itself using the same foundation model that is, in this case, Amazon Titan, to provide something that is meaningful with the same representation of the embeddings that we have in the database, to make the similarity search possible, of course. And then this data is used to retrieve all the matching chunks that are contained within the vector store, and then the output is provided to the LLM to basically finally provide the answer back to the user.
Yeah. And you'll see here it's given a very specific correct answer of exactly what poor Eve was sent to Bradford prison for. It was debt. She had 2 of her cows seized and she was thrown into jail. Right. So let's just quickly compare that. So
will it also just go back to that, Steve, as well? It
Yeah.
will also show you where it gets that information from as well, won't it? So if you do details, does it give you like the specific chunk in the document? Yeah. So yeah.
Yes, it is. It's going to show you that where it.
So if you had like multiple pieces of document in this, you can see where it's actually getting this from. So
where it sourced it from, yeah, and that's really quite powerful. So you can actually, rather than hoping it's correct and hoping it's done its job, you can actually validate that at the same time. Now let's just do a quick comparison. So this was the LLM sense checked, if you want, by Bedrock Knowledge Bases. We can just do a text chat playground. We can select our model. Again, I'm going to be very specific in picking exactly the same model, so there's no difference at all in our model that we're using, and I'm going to give it exactly the same question. So this was just what this particular model was trained on, and if we ask the question,
and typically that's just internet data, isn't it? Available data on the internet, you know, what these large language models are trained on. And this is where you can, it's a really good example of showing where a knowledge base enriches you know, your data set. So
yeah,
that's cool. I like that.
Yeah, and so if we've got time, we can get from the chat someone to pick their slightly left of center hobby, and we can find a PDF for it, and we can come up with a question to ask it. But I don't know.
If anyone's got one, if anyone's got a random hobby they want to pop in the chat, and we'll maybe get that document and load it in. I think what would be worth doing, I think, Steve, as well, is show. I think it's worth showing the audience what a vector looks like inside a Postgres as well, because I think it kind of brings it to life a little bit of how, you know, I guess how some of the magic works. The magic works by a similarity search, by a big bunch of numbers, a bit like what you were showing before. So, you know, and you can see that when you look at the rows of the data of that PDF document, of how it's been broke down into individual chunks, and then you have the chunk and the embedding and the actual metadata, you know, stored inside the database, which I think is really useful to see.
Yeah, so here's the problem: is whenever you display a vector, one that's 1,500, so what I'm showing you here is the chunk. So for this particular document, it was in, I believe, 300 chunks, wasn't it? So this is 1/300th of that entire historical document. And for this particular chunk, it will have its associated vector. Now, if I try and add the embedding,
it'll just be a big whopping number, won't it?
Yeah, or I mean, it won't display very well in PSQL, I'll be honest. I mean, let's try.
Look,
so embedding from, so that's what it looks like. Not particularly human readable, but it's very readable.
It's computer though, isn't it? You can see how, you know, the computer mind works with these numbers to be able to give you, you know, retrieve when you're doing that similarity search. It's doing it on that number of them, which then grabs the chunk of data, of which that's the most similar chunk of data to what the user requested. You know, so it kind of brings some of the magic to life a little bit, I think.
Yeah,
which is really cool to see.
And so this allows vector distance searches that basically simplify what can be very complex comparisons between items into just a simple, or I say simple, but a mathematical distance search, and then that answer can be found very, very quickly. And that's the power of this. So you can do things like fraud detection, you can do similarity searches, and so that it's just very fast at doing that, and so it enables a lot of extra use cases and reduces the chance of these hallucinations that makes people maybe trust AI a little less in some
Yeah, especially when you're just using random, like what you just did then, a large language model, which is just trained on internet data, and you're expecting it to give you the right answers, and this is where you're seeing the hallucinations, as opposed to if you're using your data set, you should see a big reduction in those hallucinations, and there's multiple use cases for this.
Yeah, and definitely, reusing a foundation model that already exists without retraining it from scratch.
Yes.
It's sort of, training it on the fly at runtime with, very fast.
Yeah, I like it, and it's useful in a business context as well, because if a LLM has trawled the internet, then it maybe will have trawled a article on your product done by a competitor, maybe a comparison, and that may not be accurate information. So it's very important to make sure that your particular users, if you're serving content and using this to enrich your content, is based on true, accurate information, not just whatever was trawled. So that's
awesome stuff. Cool. Well, we've got nobody giving us a random. Have you got any random hobbies you've used in the past, Steve? We could do.
Well, I did this as a presentation in Edinburgh, and there was a person who was interested in guns, and so we did it about the type of ammunition that could be used in certain rifles, and we got a PDF document, and we found one, and he was able to ask very specific questions about it, and then so that worked well.
But you could see, though, imagine if you was a gun shop, for example, and you wanted to give that sort of advice on your website, for example, so people don't have to trawl through big documents, where they could literally go, oh, what's my caliber for this? Where it could then, this way you start to see the use cases for it. And how simple it is to set up, certainly when you're using knowledge bases. You're not talking about lots and lots of lead time for development for it. You can quickly get yourself up and running, which I think is cool. So,
and often when you don't know something or you're not sure, so you're going to the internet to look it up, and you might get someone asking a question or has posed a similar question to you on a chat forum, and then you will get 100 answers on that. Some of them may be right, some of them may be wrong, and there's no real filter. So you almost need to have to know the answer sometimes before assessing whether these answers are correct or not. And it can just help with the quality of information that you're going to get.
We've got some questions here. So, how can building a knowledge base directly on Postgres help accelerate GenAI projects, especially when dealing with large scale and structured data? You take that?
Yeah, so it isn't the only vector store we have on AWS. So Kendra is one that was an option there. You can use OpenSearch, so that also has a vector storage facility there. So I guess we're not suggesting that to use Postgres only for vector storage. What you have to do is you have to look at the particular use case. Another influencing factor is, do you already have the other part of your application's data stored within Postgres? Do you really need to be taking the time and effort to have a second data store for your application, or do you want to consolidate them? And
also skills, maybe. I know the managed databases, but when it comes to it, the reality is you still want to have some expertise in being able to navigate with that database.
Internal knowledge and familiarity with a specific solution like this. And as you said, maybe you are already using it for your project, your architecture, and you want to co-locate your relational data, that is the metadata and the relational data, of course, together alongside with the vector, the embeddings.
Here's another nice question as well from Viral Versi. So, what specific Postgres features like PG Vector, JSONB, or indexing strategies play the biggest role in improving retrieval speed and model accuracy when integrating GenAI workflows?
Yeah, I can take this. It's a great question indeed. So basically, apart from depending on your business requirements, right? Because likely, eventually, if your knowledge base is more 100% accuracy, you can even go with an exhaustive research. Comparing the user query with all the vectors, all the embeddings that you store within your database to retrieve exactly the best matching, right? But apart from indexing to run what we call the approximate nearest neighbor searches, like the HNSW indexing method that we had a look before with, during the demo with Steve, there are other possible optimizations and best practices to improve the performances. So actually we have, let's say, three main optimizations. The first is the product quantization. That is basically the technique where we try to keep the semantic representation of the unstructured data, but trying to use less space, right? So it's what we call the principal component analysis. And basically with the PG vector, what we do is, during this demo, we saw that we were using the vector data, but it's not the only data type that is available through PG vector. We also have, for example, the half-vec data type that uses a representation of the scalars inside, the arrays with a representation of 2 bytes instead of 4 bytes. That is the representation with, the vector data type. And this way we are preserving the most meaningful bits of the content, principal component analysis, the first 2 bytes. And of course, this can save money because you will need less storage to store both your data and the indexes. Improving performances because, the indexes, as I said, are smaller. You will need less memory and CPU to elaborate the same information. While the other two options are, and I just linking back to what I said before, hybrid searches, for example, combining the best of the two worlds, and that's another, let's say, powerful option that Postgres provides, because basically you will use the PG vectors semantic vector search plus the traditional PostgreSQL full text search using, the document itself, the text information eventually, if it is a matter of a full text search, of course, the metadata. And basically, this approach is particularly powerful when, because it allows you to find results that are both semantically and lexically relevant, right? And finally, the third option is re-ranking. That is a technique for improving the quality of the search results using a two-phase process. In the first phase, basically, you have the initial retrieve, where a larger set of potentially relevant results is retrieved using fast but potentially less precise research method. While in the second phase, basically the reordering, the re-ranking, basically these partial results are analyzed in more detail and reordered according to more sophisticated and computationally intensive criteria. So, these three practices, when implemented and possibly combined correctly with the eventually even using some weights, why not? Depending on your data, right? They form the backbone and of a robust and performing GenAI system based on Postgres. The key, in my opinion, is to find the right balance between accuracy and the performances, of course.
Yeah. Just to add to that, so vectors and vectored indexes tend to be quite heavy on the use of memory as well. So we also recommend for the scenarios where you need the most performance is to use the optimized read Aurora instance class, and that then performs better with vector workloads where you do have to move large amounts of data from the storage into memory and process them. So that lends itself quite well to that.
Yeah. That's a great point, Steve, because optimized reads is basically an infrastructural improvement, if we want to say like that. It's basically leveraging the and local attached NVMEs that come some special instance families for Aurora. And this storage is used both to support large sorts that do not fit in memory. Plus, it is also used as a tiered cache, as a second layer for the database cache, right? And we know that the um, workloads like pgvector, but not only, also PostGIS, for example, they are very memory intensive, right? And local attached NVMe storage is 6 times the size of the memory, right? And in Aurora, I would say it's not the only let's say hardware improvement you can get, because the other one is the Graviton processors. And you remember when I said, we are actively as AWS contributing to the pgvector project. Now pgvector can leverage and take advantage of the hardware acceleration provided by the Graviton processors. That's another benefit.
Very good.
Yeah, I just posted. Well, I'll post in a minute. A blog on the optimized read stuff you just talked about. We have a detailed blog where you can see the performance increases for you when you're using vectors. So well worth taking a read of that. So we're coming towards the end of time now. So we did get somebody posting up saying doing magic as a hobby, but unfortunately, I don't think I'm going to have time to load that in. But I tell you what, do give it a try yourself. I think it'd be interesting to see the results of it. So
probably, Tony, last bit is maybe if you can show the slide.
Yeah, sure. Yeah, let me get this up. Yeah.
Really the last. Well, this is another benefit, eventually by.
Yep.
There is this very very smart extension, AWS ML, where basically directly from the SQL code you could interact with Amazon Bedrock, for example. Not only you can also interact with SageMaker and so on, but just closing the cycle of this discussion, you can go directly on Amazon and eventually get invoke some foundation model and get your embeddings. Why not with the database that is driving this, either synchronously or asynchronously, right? There are multiple options, and maybe you would like to provide a link. I've published a blog post together with another colleague.
Yeah, I will share that.
Yeah, you can automate the embeddings by leveraging this integration. That's powerful in my opinion.
Yeah. And any links we've not shared today as well, we'll also do our show notes as well, and we share them in that link as well. I'm just going to post some more links in there as well, which will be shared. I just what we're doing for time. We've got just another 1 minute, so I think I'll end with. What would you say are the key differences between using key differences for using Postgres versus other vectors? We have a good doc on it, as I'm going to share as well. But just to sum that up, what would you say that they are from your perspective?
Yeah, well, as I said at the beginning, PostgreSQL provides out of the blue a lot of features. It's robust. You have built-in security, role-based access policies, those kind of things that are, in my opinion, valuable. And especially if you are already leveraging it, the possibility of co-locating your relational data and the metadata with, the embeddings to implement, the strategies I mentioned before, not only quantity, but especially hybrid searches plus ranking. I've seen this, make the difference, definitely.
Yeah, And I guess some of the innovations in Postgres Aurora as well. I think
Yeah.
some of the ones we
Yeah.
talked about really help as well, don't they? So
yeah.
excellent. Thanks for being on today, guys. A really cool demo. I like seeing. I think it's the mad side of me where I think like seeing demos what go wrong, especially live demos. So that was good to see, and you recovered that quick, Steve, which was great, and we actually got to see it in action, which was really good as well. And thanks for everyone who's been posting on the chat today as well. That's been great. So we won't be back here next week because reInvent's on. So you will be able to go onto the Twitch channels, Twitch AWS. There'll be shows throughout there, but we won't be airing that week. We are back on the 8th of December. So we're going to be doing building a marketing assistant with Curio and QuickSuite for a non-tech person. So really interesting show to take a look at there. And that's going to be at 5 p.m. CET, 8 a.m. Pacific time, and 11 a.m. Eastern time on twitch.tv/AWS and also YouTube AWS events. You can also email us and see our past shows. I'll put those in the chat now as well. So if you want to see any topics or you want to talk to us about anything, do drop us an email. Also visit our community page as well. That will have links to our show notes. So today's show will be on there, and you can also get it on catch up as well through the show notes. So thanks again, Domenico and Steve. Top show.
Welcome.
Always a pleasure. And thanks for everybody joining today. Cheers, everybody.
Thanks, folks. Cheers.
Bye.